There is no specific national electrical code requirement mandating copper conductors for X-ray machine installations. The code contains general requirements for installing electrical equipment. Article 110.3b states conductors and equipment shall be suitable for the conditions of use and location. Article 250.118 states service conductors shall be sized in accordance with the loads supplied. While the National Electrical Code doesn't mandate copper conductors, the X-ray machine manufacturer's installation instructions may require them. Manufacturer's instructions are considered conditions of use under Article 110.3b. Number 2 service entrance rated aluminum cable is rated for 100 amps according to the 2023 National Electrical Code Table 310.15b16. Therefore, from a code compliance standpoint, these conductors are acceptable for the 100 amp X-ray machine. Based on the information provided, there is no code violation in using the number 2 service entrance rated aluminum cable for the X-ray machine. However, the manufacturer's installation instructions should be checked to ensure that they do not specifically require copper conductors. If they do, the aluminum cable will need to be replaced with copper. Ampacity is the current, in amps, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Several factors affect ampacity, including the conductor material, size, insulation type, and the ambient temperature. National Electrical Code tables provide ampacity ratings for various conductors based on these factors. Aluminum conductors have a lower ampacity than copper conductors for the same size. This is because aluminum has a higher resistance to electrical current flow than copper, which generates more heat. Therefore, aluminum conductors need to be larger than copper conductors to carry the same amount of current. The National Electrical Code specifies the allowable ampacities of conductors in Article 310. These ampacities are based on the conductor's insulation type and temperature rating. Common insulation types include THHN, THHW, and XHHW. Each insulation type has a specific temperature rating, such as 75 degrees Celsius or 90 degrees Celsius. The ampacity of a conductor decreases as the ambient temperature increases. This is because the conductor's insulation can degrade at higher temperatures, reducing its ability to carry current safely. The National Electrical Code provides adjustment factors for ampacity based on ambient temperature in Table 310.15 bone and correction factors in 310.16. When multiple current-carrying conductors are installed in the same raceway, cable, or enclosure, the heat generated by each conductor can raise the overall temperature, reducing the ampacity of each conductor. The National Electrical Code requires that the ampacity of conductors be derated when multiple conductors are present in the same raceway or cable, as seen in Table 310.15 colon. The amount of derating depends on the number of current-carrying conductors. The termination temperature rating is the maximum temperature that the conductor termination, such as a lug or connector, can withstand. The National Electrical Code requires that conductors be terminated in equipment that is rated for the conductor's temperature rating. This is to prevent overheating and potential fire hazards. Equipment is marked with its termination temperature rating. Conductors must be sized to match the lowest temperature rating of any termination conductor or device in the circuit. Voltage drop is a decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using Ohm's law, which states that voltage drop equals current times resistance. To minimize voltage drop, conductors with lower resistance or larger sizes can be used. Aluminum conductors have a higher resistance than copper conductors for the same size. This means that aluminum conductors will experience a greater voltage drop than copper conductors for the same current and distance. To compensate for this, aluminum conductors need to be larger than copper conductors to achieve the same voltage drop. The National Electrical Code provides guidance on conductor sizing to minimize voltage drop. The NEC Chapter 9, Table 8 provides the alternating current resistance and reactance for conductors. Grounding ensures a safe path for fault current to return to the source, minimizing the risk of electrical shock. The National Electrical Code requires that all electrical equipment be properly grounded. Grounding conductors can be made of copper or aluminum. The size of the grounding conductor depends on the size of the ungrounded conductors. Grounding electrode conductors connect the grounding system to a grounding electrode, such as a ground rod or water pipe. The National Electrical Code specifies the requirements for grounding electrode conductors. Bonding connects different metal parts of the electrical system together to create a low impedance path for fault current. The National Electrical Code requires that all metal parts of the electrical system be properly bonded. Bonding conductors can be made of copper or aluminum. The size of the bonding conductor depends on the size of the ungrounded conductors. Conduit protects conductors from physical damage and provides a path for grounding. Conduit can be made of metal or non-metal materials. The National Electrical Code specifies the requirements for conduit installation. The type of conduit used depends on the application and location. Common types of conduit include rigid metal conduit, electrical metallic tubing, and non-metallic conduit. Raceways are enclosed channels designed to hold wires or cables. Raceways can be made of metal or non-metal materials. The National Electrical Code specifies the requirements for raceway installation. The type of raceway used depends on the application and location. Cable trays are open support systems for cables. Cable trays can be made of metal or non-metal materials. The National Electrical Code specifies the requirements for cable tray installation. The type of cable tray used depends on the application and location. Electrical boxes enclose electrical connections and protect them from physical damage. Electrical boxes can be made of metal or non-metal materials. The National Electrical Code specifies the requirements for electrical box installation. The size and type of electrical box used depends on the number and size of conductors being terminated. Connectors are used to connect conductors to equipment and to each other. Connectors can be made of metal or non-metal materials. The National Electrical Code specifies the requirements for connector installation. The type of connector used depends on the type of conductor and equipment being connected. Lugs are used to terminate conductors to equipment. Lugs can be made of metal or non-metal materials. The National Electrical Code specifies the requirements for lug installation. The type of lug used depends on the type of conductor and equipment being terminated. Wire nuts are used to connect two or more conductors together. Wire nuts are made of plastic and have a metal insert. The National Electrical Code specifies the requirements for wire nut installation. The size and type of wire nut used depends on the number and size of conductors being connected. Splices are used to join two or more conductors together. Splices can be made using various methods, such as soldering, crimping, or using connectors. The National Electrical Code specifies the requirements for splices. The method used for splicing depends on the type of conductor and the application. Overcurrent protection devices protect electrical circuits from overloads and short circuits. Overcurrent protection devices include circuit breakers and fuses. The National Electrical Code specifies the requirements for overcurrent protection devices. The size of the overcurrent protection device depends on the ampacity of the conductors being protected. Circuit breakers are resettable overcurrent protection devices. Circuit breakers trip when the current exceeds the breaker's rating. The National Electrical Code specifies the requirements for circuit breakers. The type of circuit breaker used depends on the application and the voltage and current rating of the circuit. Fuses are non-resettable overcurrent protection devices. Fuses blow when the current exceeds the fuse's rating. The National Electrical Code specifies the requirements for fuses. The type of fuse used depends on the application and the voltage and current rating of the circuit. Ground fault circuit interrupters, or GFCIs, protect people from electrical shock. GFCIs trip when they detect a ground fault. The National Electrical Code requires GFCIs in certain locations, such as bathrooms and kitchens. Arc fault circuit interrupters or of size protect against fires caused by arc faults. A size trip when they detect an arc fault. The National Electrical Code requires a size in certain locations, such as bedrooms. Surge protection devices protect electrical equipment from voltage surges. Surge protection devices divert excess voltage to ground. The National Electrical Code recommends surge protection devices for sensitive electronic equipment. Transformers are used to step up or step down voltage. Transformers consist of two or more coils of wire wound around a common core. The National Electrical Code specifies the requirements for transformer installation. The type of transformer used depends on the application and the voltage and current ratings. Motors convert electrical energy into mechanical energy. Motors are used in a wide variety of applications. The National Electrical Code specifies the requirements for motor installation. The type of motor used depends on the application and the voltage and current ratings. Lighting provides illumination. Lighting can be provided by various sources, such as incandescent lamps, fluorescent lamps, and light-emitting diodes, or LEDs. The National Electrical Code specifies the requirements for lighting installation. The type of lighting used depends on the application and the desired level of illumination. Appliances are electrical devices used in homes and businesses. Appliances include refrigerators, ovens, and washing machines. The National Electrical Code specifies the requirements for appliance installation. The type of appliance used depends on the application and the desired features. Heating, ventilation, and air conditioning, or HVAC systems provide heating and cooling. HVAC systems consist of various components, such as furnaces, air conditioners, and ductwork. The National Electrical Code specifies the requirements for HVAC system installation. The type of HVAC system used depends on the application and the desired level of comfort. Renewable energy systems generate electricity from renewable sources, such as solar and wind. Renewable energy systems include solar panels and wind turbines. The National Electrical Code specifies the requirements for renewable energy system installation. The type of renewable energy system used depends on the available resources and the desired level of energy production. The service entrance is the point where electrical power enters a building. The service entrance consists of the service conductors, service equipment, and metering equipment. The National Electrical Code specifies the requirements for service entrance installation. The size of the service entrance depends on the electrical load of the building. The grounding electrode system is a system of interconnected grounding electrodes that provides a low impedance path to ground. The grounding electrode system consists of grounding rods, ground plates, and underground metal water pipes. The National Electrical Code specifies the requirements for grounding electrode system installation. The type and size of the grounding electrodes depend on the soil conditions and the electrical load of the building. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding is essential for electrical safety. The National Electrical Code specifies the requirements for bonding. The type and size of bonding conductors depend on the size of the ungrounded conductors. Overcurrent protection is the protection of electrical circuits from overloads and short circuits. Overcurrent protection is provided by circuit breakers and fuses. The National Electrical Code specifies the requirements for overcurrent protection. The size of the overcurrent protection device depends on the ampacity of the conductors being protected. Ground fault protection is the protection of people from electrical shock caused by ground faults. Ground fault protection is provided by ground fault circuit interrupters, or GFCIs. The National Electrical Code requires GFCIs in certain locations, such as bathrooms and kitchens. Arc fault protection is the protection against fires caused by arc faults. Arc fault protection is provided by arc fault circuit interrupters, or FSIs. The National Electrical Code requires FSIs in certain locations, such as bedrooms. Surge protection is the protection of electrical equipment from voltage surges. Surge protection is provided by surge protection devices. The National Electrical Code recommends surge protection devices for sensitive electronic equipment. Electrical safety is the practice of working with electricity in a safe manner to prevent electrical shock, fires, and other hazards. Electrical safety is essential for all electrical workers and anyone who works with electricity. The National Electrical Code provides guidance on electrical safety practices. Safe work practices include wearing personal protective equipment, such as gloves and safety glasses, and following lockout/tagout procedures. Electrical inspections are conducted to ensure that electrical installations comply with the National Electrical Code and other applicable standards. Electrical inspections are typically conducted by licensed electrical inspectors. Electrical inspections help to ensure electrical safety and prevent electrical hazards. Electrical permits are required for many electrical installations. Electrical permits are issued by local building departments. Electrical permits help to ensure that electrical installations are performed safely and in compliance with the National Electrical Code. The National Electrical Code is a comprehensive set of standards for electrical installations. The National Electrical Code is updated every 3 years. The National Electrical Code is adopted by most states and local jurisdictions. The National Electrical Code is essential for electrical safety. Electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements. Resources for staying up to date on electrical codes and standards include the National Electrical Code, the National Electrical Manufacturers Association, and the Underwriters Laboratories. Aluminum conductors have specific considerations when used in electrical installations. Aluminum expands and contracts more than copper with temperature changes. This can lead to loose connections over time. To prevent loose connections, use connectors and terminals specifically designed for aluminum conductors. These connectors are typically made of aluminum or are plated with aluminum. They also have a larger contact surface area to distribute the pressure evenly. Aluminum conductors oxidize when exposed to air, forming a layer of aluminum oxide on the surface. Aluminum oxide is a poor conductor of electricity, which can increase resistance and heat. To prevent oxidation, use an antioxidant compound when making connections with aluminum conductors. Antioxidant compounds prevent the formation of aluminum oxide and improve the conductivity of the connection. When terminating aluminum conductors, follow the manufacturer's instructions for the specific connector or terminal being used. Proper termination techniques are essential for ensuring a safe and reliable connection. Over-tightening can damage the conductor or connector, while under-tightening can lead to a loose connection. Regularly inspect aluminum connections for signs of looseness or corrosion. If any problems are found, tighten or replace the connection as needed. Proper maintenance can help prevent problems and ensure the long-term reliability of aluminum connections. Aluminum conductors are typically less expensive than copper conductors. This can make them an attractive option for cost-sensitive projects. However, it is important to consider the specific requirements of the application and the potential for increased maintenance costs before making a decision. Aluminum conductors are lighter than copper conductors. This can make them easier to handle and install, especially in large sizes. The lighter weight can also reduce the structural load on buildings and equipment. Aluminum conductors have a higher resistance than copper conductors. This means that they will experience a greater voltage drop for the same current and distance. To compensate for this, aluminum conductors may need to be larger than copper conductors. The size of the conductor will depend on the specific application and the allowable voltage drop. Aluminum conductors are more susceptible to corrosion than copper conductors. This is especially true in environments with high levels of moisture or salt. To prevent corrosion, use conductors and connectors that are specifically designed for corrosive environments. Also, ensure that all connections are properly sealed to prevent moisture from entering. Aluminum conductors have a lower tensile strength than copper conductors. This means that they are more likely to break or stretch under tension. When installing aluminum conductors, avoid pulling them too tightly. Also, use proper support methods to prevent sagging. Aluminum conductors have a higher coefficient of thermal expansion than copper conductors. This means that they will expand and contract more with temperature changes. When installing aluminum conductors, allow for expansion and contraction to prevent stress on the conductors and connections. Use expansion fittings where necessary. Aluminum conductors have a lower melting point than copper conductors. This means that they are more susceptible to damage from overheating. When using aluminum conductors, ensure that they are properly sized and protected by overcurrent protection devices. Also, avoid overloading the conductors. Aluminum conductors are not compatible with all types of equipment. Some equipment is designed only for use with copper conductors. Before using aluminum conductors, verify that the equipment is compatible. If the equipment is not compatible, use adapters or other means to ensure a proper connection. Aluminum conductors require special tools and techniques for installation. It is important to use the correct tools and techniques to ensure a safe and reliable connection. If you are not familiar with the proper installation methods, consult with a qualified electrician. Aluminum conductors are a safe and reliable option for electrical installations when properly installed and maintained. However, it is important to be aware of the specific considerations and requirements for aluminum conductors. By following the recommendations in the National Electrical Code and the manufacturer's instructions, you can ensure a safe and reliable electrical system. The information provided in this narration is intended for general guidance only. It is not a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. The National Electrical Code is a complex and ever-changing document. It is important to stay up to date on the latest requirements. The National Electrical Code is published by the National Fire Protection Association. Copies of the National Electrical Code can be purchased from the National Fire Protection Association or from other sources. The National Electrical Code is available in both print and electronic formats. The National Electrical Code is an essential resource for electrical workers and anyone who works with electricity. The National Electrical Code provides guidance on electrical safety and helps to prevent electrical hazards. The National Electrical Code is a valuable tool for ensuring the safety and reliability of electrical systems. The National Electrical Code is a living document that is constantly being updated to reflect the latest technological advances and safety concerns.